So the next notebook we're going to go through, you go back to your notebooks directory in the IPython or Jupyter notebook server. The notebook we're going to work on is called Siphon _cartopy _metpy _her. All right. Between her and wharf, it sounds like a frat party gone wrong. Okay, so starting out here, cell 1, it's our normal get up and go. We import matplotlib.pyplot as plot, import numpy as np. Nearly every script I write at least has that in it. So I'm going to be crunching some kind of number, and I'm going to be looking at, even if it's just a simple plot, just to check out what's going on. And then, of course, the matplotlib inline. So go ahead and execute that. And so what we're going to do in this is we're going to access a very beefy data set remotely, and in what I would call a smart way, as opposed to going to the data server that has this file or this data set, downloading the whole thing just so that you can plot one 2D grid and decide, do I actually want to use this data set or not? And so our data set of choice here is going to be the her data set. And in cell 2, we have our import statement from siphon.catalog. So Siphon, like, when it's 3 in the morning, you're not sure if you can get out to get some munchies. And so take the tube, put it in your neighbor's car, get a little gas. You're going to get them more gas. You help them out. So Siphon, in this case, we're siphoning off data from a data server. And we're going to import a function that's called getLatestAccessURL. So there's a URL here. Right now we call it her catalog. Go ahead and, if you want to follow along with this part, copy that guy all the way over to XML. Let's take a look at what we're dealing with. So if you're following along, you see something like this. Doesn't that look lovely? You just want to read everything in this format, right? So this is called XML. It's a markup language similar to HTML. That's what it kind of looks like. It would actually be a superset of HTML. But this contains information from our Threads data server running back in Boulder. And basically it tells you stuff like, here are some services we provide. And so some of these may sound familiar, like OpenDAP. You may have heard of OpenDAP before. We use netcdf for Python to actually talk to an OpenDAP data server through an OpenDAP URL. There are some other things in here you may not have heard of, like, or may have casually heard of, like a web mapping service, WMS, or NCSS, the netcdf subset server. So it tells us what kind of services that we can get, and then it lists out information about the data set you're looking at. Now again, this looks kind of gnarly. It's not all that fun to stare at. Turns out computer programs will suck this in and chew on it and just sing zippity-doo-dah. Knows how to deal with this, and it loves being able to crunch through documents like this. So very much machine readable, human readable. It's definitely not as nice as Markdown is. Now, if you go to the URL and change that extension from XML to HTML, the Threads data server goes, oh, this is a person. Let me make this look like something a person might want to actually look at. And so we can see across the top here, it's got a URL in big letters. It mentions her. And then if we look right under data set, we see incept her 2.5 kilometer CONUS. And then various links, and these are actually links to individual runs of the her. So the her runs every hour. This outputs on a 2.5 kilometer grid. And so we want to play with some of this data without downloading it. These her files are around 4 or 5 gigabytes each to download and run. If you're dealing with the GFS quarter degree, which is another data set we have on our thread server, you're looking at about 20 gigs per run on that guy. So, you know, the feasibility of downloading the whole grib file is not all that great. And then what do you got, or what do you have? You have a 20 gigabyte grib file. And if you've worked with grib, hopefully you can understand why that in itself is an issue. But so what would be nice is if we could access this grib data in a way that I don't have to download every single byte that's on disk remotely, and in a way that looks like I'm just accessing it as if it were a netcdf file, where I have 3D variables and I can, you know, slice and dice and ask for exactly what I want and get that back, and everyone calls it a day. Now, yesterday and a little bit the day before, Pete and I had some fun. And so if you change the first part of your URL from threads.ucar.edu to weather.wisc.edu, so weather.aos.wisc.edu:8080, and then go to that page. Hey, you guys have her data here too on a thread server. Hooray. So rather than going to Boulder and talking to a remote data set there, which we certainly can, why don't we use the local network infrastructure and talk to the data set using AOS's thread server? That's going to be a little bit quicker. Plus, no one really knows about this except you guys now. And so this machine isn't bogged down like the one we have back in Boulder. So it should respond a little quicker. Okay. So if I go down into one of these files, let's say, hey, what's this? Latest collection for inset per CONUS 2.5 kilometers. So latest. So the latest run of the model. That sounds good. And it looks like we have 14Z from today. That's the latest one we've got on disk. We can click down through there and we can see some information about this particular data set. It's in grib 2. That's lovely. Tells us a little bit of information. And then we have these things called access. So some of these access links will take you somewhere useful. Like I can go to the netcdf subset service. It's going to take me to a web page where I can select variables, enter like a latitude, longitude bounding box, enter my time bounds, and I'll just click a few things here. And really what this page is doing is at the very, very bottom, I know you guys won't be able to see this in the back, but at the very bottom of the page it says NCSS request URL. And so this is actually building a URL for you. And that looks like a pretty gnarly URL. But that's how you interact with this netcdf subset service itself. And so if you were to submit this after filling in some of the parameters, what you would get back is a netcdf3 or netcdf4 file containing the data that you wanted. Now going to this page every day and clicking around and getting the data you want can be a pain. So doing programmatic access to netcdf subset service is something we've done in the Siphon library, and we've tried to make it to where it makes sense so that you can request just the data you want and get that back. Now, if you recall, we also have used OpenDAP. So if I look at the OpenDAP, it also gives me a page. And here I can go through and select variables that I'm interested in. So for example, the echo top of the clouds, and it's asking me for kind of an index expression of how I would want to get into that array of data. Generally, I don't care if I'm not familiar with the data set, what index of the array I want. What I care about as a user is I want it over this physical location on Earth from time A to time B. Not I want time, 5 from X 3 through 27 and Y 5 through 15. Like that, I can't process that in my brain. I'm not familiar with the data set enough to do that. But if I got to ask for it in geophysical space with expressions like latitude equals, 50, then I'm going to be a much happy camper. And so the OpenDAP and NetCDF subset service, those are two ways of remotely getting at data without needing to download it. And some of these access methods, if you go to it like the WMS link, you get something like this, and it's just a big old honkin' XML file. Now this on its own, you wouldn't necessarily download and look at and study and try to figure out what's going on, but there are clients that will use WMS and knows how to talk to a WMS server. One of those clients is called Godiva 2. It's a JavaScript-based client. And if you go down to the very bottom of this page, you can actually see a link for Godiva 2, click it, and now you've got this web-based interface. I'll shrink it down, where you can select, okay, total precip, 1 hour accumulation. The scale's stupid, so I want to auto scale this, so I can click around. If I want to make this transparent a little bit, I can. I can zoom in over this layer. Oh. Let me zoom in here so you can kind of see what's going on. The color scale blows, so I can change that. I can also change the background map. Blue marble is kind of cool, so we'll use blue marble. If I click on the color scale, I get some choices here. I can do something like that. I'm going to zoom out again. So there are lots of different things I can do with this interface, and it's a pretty simple interface, but that's all talking across WMS. And believe it or not, there's no actual data values from an array being passed back. WMS actually sends around image files or Google Earth KMZ or KML files. So even if it looks like an access method on the threads page doesn't do anything, like it just gives you a big gobbledygook of XML, it's actually useful by some other libraries. And there's a Python library that will let you talk through WMS and get back image files from the server. So rather than, if we go back here, actually here, so rather than pulling back a 2000 by 2100 by 1300 point grid across the network, I could ask for a 10 kilobyte ping image to come back just to give me a quick look at the thing. And so there are definitely advantages to requesting an image unless you want to do analysis on it. At any rate, we want to be able to do all this stuff using Python. And there are lots of threads data servers out and about in the world. INCEP or NCDC runs a thread server, for example. There's a thread server in the Amazon cloud that allows you to request radar data if it can detect that you're coming from an EDU. Non-EDU people, we haven't figured out how to deal with that because Unidata is actually paying a bit of money when you request from that server and that comes back to the data come back to your machine, that costs some money. And so Unidata is footing that at the moment. We'll do that for EDU users, but not crazy Finland Weather Service or, well, Finland Weather Service, I don't think, we wouldn't cover that. And certainly not, the guy in a German cafe making an Android app. We're not going to pay for his data transfer. That would just get ridiculous. Anyways, so first thing we want to do is this her catalog. Let's change it from threads.ucar.edu to the local server. So weather.aos.wisc.edu:8080.
With an XML or HTML at the end?
XML's at the end. Yep. And I think Siphon at this point, if it sees HTML, it'll go ahead and replace it with XML because that's what it wants.
I get an error. HTTP.
So don't forget at the end, there's a colon 8080.
Around that URL needs to be restricted.
And so we've put this catalog link in here. We've passed that to Siphon's get latest access URL. And we said, Siphon, I want you to look at this catalog and see if you can find the netcdf subset service access link for me for the latest run of this model. That's how you would kind of say that in words and not just random things like get latest access URL. So what that's going to do is give us the access URL so we can start to talk to the netcdf subset service. And what we want to do is be able to set up something that will allow us to tell Siphon what we're wanting. And that thing we want is called an NCSS object. So we can import from siphon.ncss, import NCSS. And the thing that NCSS, this object, wants is an access URL. And so when you execute this cell, it's going to go out and look at this XML catalog, which is just a couple, kilobytes. And it's going to look at all the data sets available, grab the latest one for you, and create something that will now allow you to tell the service what you want to get. And the way that the user tells the service what it wants is by creating a query. So on this NCSS object, we can do a .query, and that's going to start taking things for us to make our request. Now to keep this separate here, we've added these four values: lat, lon, width, and height. Normally what Siphon wants is the western longitude, the eastern longitude, the southern latitude, and the northern latitude of a box containing the data that you want to get back. For me, I like being able to say, center it at this point and give me a 20-degree by 25-degree box around it in terms of a width and height. And so when we do the query, we're going to be changing this into lat-lon bounds. So there's just a little math in the query that we do. But at any rate, so here's our query. And the first thing we do is say query.allTimes. So I want all of the time steps when I make this request. And then we can chain onto that another dot and say .accept. I want that returned to me in netcdf4. What that means is the data is going to be compressed before it's sent back to us. And then we can do a .variables and say, I want this variable. So temperature, height above ground, that's one of the variables in that file. We're going to play with that. Yep. And then we're going to give it a lat-lon box. So query.lat-lon box. And here's where we're using the height and width in order to make it an actual north, south, east, west bounding box. And so far, all we've done is got back just a couple kilobytes of information from the server. But when we execute this .getData method on the NCSS object, we're going to send that URL over to the server. We're going to put it there, or do a GET request on it, and then the server is going to go, okay, cool. Let me see what I can get you, and it's going to look through the GRIB files, find the data that you've been asking for, and then it will write that out to a netcdf4 file and transfer that back to us. So if we execute this cell, it takes a couple seconds for it to actually be able to go out to the server, and the server go through what could be multiple GRIB files behind the scenes and grab the data that you're interested in and send it back. So yeah, I mean, it's already done. It's done halfway through while I was talking. So that's not too bad, really. And what do we get back? We saved it to this thing called NC. And so if we just execute the next cell and see what NC is, hey, it's a netcdf4 data set, which is what some of us tried to play with yesterday, and others got anaconda'd, I suppose. And so again, so the netcdf4 data set, if you print that out, or if you look at it, just the output from saying execute that cell, you're going to see the global metadata. There's a whole lot more global metadata in this thing. And then eventually the output kind of gets cut off. So we asked the server, we said, hey, I want temperature height above ground. And the server said, okay, cool. So that has a time, a height above ground, an X, and a Y dimension. So let me go ahead and grab those dimension or those coordinate variables for you too, so you can actually have what height above ground you are, a numerical value for that, and what your X and Y grids are, and what your time is. So we actually got a file back with not just the variable we wanted, but the coordinate variables associated with. So we have time, we have height above ground, we have Y, we have X, and we also have this thing called a projection variable. We'll talk about the projection variable here in a bit. So if we create, if we want to grab the information from that netcdf variable, remember you can take the netcdf file object and it's a dictionary call. So I'm just saying nc var or nc, so that's the netcdf file. Put in the name of the variable I want, I get back a netcdf variable. So here we go, it's a float 32 field. It's got these dimensions, it has a unit of Kelvin. We have an abbreviation that's actually coming out of a GRIB table somewhere. This gives us the GRIB gnarly information, so you can have that if you want. Now what's interesting is there's an attribute on this temperature file, or this temperature variable, called grid mapping. So what the heck is grid mapping? So I want to create a new thing to hold this grid mapping variable. So what I'm saying is from this NC file, so NC points to the netcdf file, from my temperature variable, give me the name of the grid mapping, and then that thing's going into the dictionary call on NC. And so we see we have this thing called grid mapping. You can look at the name and get an idea of what it is, but the important things in here are the attributes on it. So the grid mapping name is Lambert conformal conic. Here's some information about that map projection. And so, for example, here's what the radius of the Earth was assumed to be when INSEP ran this model and geolocated it in projection space. And so, why would we even want this? Why would we care about the projection information? Well, let's go back and look at what we were given in our data file. If we look at the variables we got back, let's see here. We got temperature at height above ground, and we got a Y, and we got an X, but I don't see a latitude or a longitude in there. So why would they just send us the actual grid that the numerical model was run on instead of a field of latitude and longitude? Well, as the models get bigger and bigger and bigger, you can imagine if you're running it in a projected space, your latitude and longitude is actually going to be, each one of those will be a two-dimensional array. And I'll show you why here in a second when we actually plot this guy up. But if you're sending back a two-dimensional array for latitude and a two-dimensional array for longitude, that can get really, really big. So instead, what they do is they send you back the one-dimensional array of the X values and a one-dimensional array of the Y values. And those X and Ys combined with that grid projection, you can create on your end what the latitude and longitude values should be. Now, if you've done projection math before, that can be a very painful thing to go through. But thankfully, there's a library called Cartopy that knows about projection math, and it'll let you take X and Y's and translate that into what a latitude and longitude would be, given a set of projection parameters and projection information. So that's pretty sweet that you don't have to do that. Now there's other plotting libraries out there. One of them is Basemap, and Basemap struggles trying to do this sort of thing. It can do it sometimes, but there's some underlying assumptions and some conflation between what the grid looks like, or some conflation between the concept of a grid and a grid in projection space. And so sometimes you can't do it with Basemap. It's one of the reasons we've decided to go with Cartopy. Basemap's made by Jeff Whitaker, the same guy who makes NetCDF for Python, and it's good for what it does, for sure. Cartopy is actually being developed out of the UK Met Office, and it has a team of software developers behind it. And the interface to it's a little bit cleaner, and it seems to have more functionality that will allow us to do things we need to do, especially when working with model output from INSEP. And so all I'm going to do here is save out these projection parameters into their own variable set as soon as I actually execute the cell above it. There we go. So I've just stored things like the latitude of the projection origin in a Python variable, so I can grab it in an easier way. And so now what we want to do is use Cartopy and figure out how these XY values map to latitude and longitude. And so we can import Cartopy and Cartopy CRS, which is the coordinate reference system stuff within Cartopy. And then because we know ahead of time, or I knew ahead of time, that Cartopy really wants things in terms of units, or in terms of meters. It wants the X and Y in meters. What we get from INSEP is actually in kilometers. And so I'm pulling out for variables X and Y. Oops. So what I'm doing is I'm using the netcdf variable for X and the netcdf variable for Y, doing a .units on that to get the unit out from the netcdf file. And then I'm printing what the units are. So both X and Y are in kilometers. Cartopy wants it in meters, so I can use Metpy to transform it X 2 meters and Y 2 meters. And now our X and Y arrays are in meters instead of kilometers. Now, one of the things that Cartopy needs is it needs to know what kind of globe you're on when it's talking about doing projections onto a globe. And so we're going to use this WSG84. I forget where that code comes from. Proj 4. That's the default for that's the default for Cartopy. We could actually define our own globe. We could define it as a sphere or a spheroid if we wanted. We could give it an axis. So we know the Earth radius that was assumed in this. So we could actually do a little bit more specific than WGS84. But for now, we'll do WGS84. And now I'm going to define my coordinate reference system. So we know it's on a Lambert conformal projection, and in Cartopy, Lambert conformal expects certain parameters to be passed in. Again, if you go inside of right after the parenthesis here in Lambert conformal, hit Shift Tab, you'll see what the function call is. So it assumes some things if you don't provide it, like if you don't provide a central longitude for the projection, it'll go with 96 degrees. If you don't add a false easting or false northing, it'll use 0. So it'll show you what the default values are. But we know what the central latitude, central longitude, what the standard parallels are. And we're saying apply that on this globe for me. And so with that, we've set up our projection space. And then all I've done here is just, I'm printing out the size of the variables we're dealing with. So X is, 949 in length, Y is 973 in length. And then our temperature variable has 16, it's 16 by 1, and then Y and X. And so this 16 is actually temperature, or time. So we got 16 time steps back. This next one is going to be height above ground, so it's only at one level above the ground. And what we need to do is find the variables that correspond with, say, height above ground or time, and deal with those. Now, time, like I said yesterday, time's always fun. And so when trying to pull out the proper time variable from a GRIB file, it's even more fun, because a GRIB file, you don't have to go here, but I'll show you. If I go to netcdf subset service for this HER data set, a GRIB file can have multiple time coordinates in it. So here are variables with this set of times, and then they have various height coordinates. Here are some variables with this set of times. So these guys have a different set of times or different time coordinate axis. And then categorical ice pellets, it's a special flower, so it gets its own time axis. And so we need to figure out which time variable we actually want. So not too hard to do. That's what this little loop's doing. And then I'm using netcdf for Python's num to date. So the values of seconds since 1800 or whatever, and then the actual unit used. And I'm doing that, pulling that unit out programmatically because I can, since the unit's encoded in the netcdf file I've got. And time is now a Python date time object. And so it looks like June 23rd, 21 UTC, or June 23rd, 21, and then 0 hours, so 21 UTC. So now I want to actually visualize this grid. So I got the data, I've got the X and Y from the grid it was run on. I've set up some transformations to try to make that be something I can plot over a map. And now I just need to tell matplotlib a little bit about what I would like to do, and we'll be good to go. So I'm just going to pick one time step here. I'm going to go with the first one. That's the model initialization time, not the actual analysis field from the grid. Or not model initialization. This is the first forecast hour from the model. And even though that forecast hour is 0, it's not the same as the analysis field from the model. So at INCEP, what they do, they spin up their models using some kind of assimilation, and they get an input field that they can put into their model as their initial conditions. They'll run that one time stamp or one time iteration through, maybe 10 time iterations through, to make sure that the observations and whatnot are consistent with the model physics. So transform observed data into the model fantasy land. Please don't take offense to that. I'm an observationalist, so sometimes my biases come through. And then that time equals 0 is after the model's integrated that initial field a couple times. And then I'm also I know ahead of time, I want to add some things to our map, like state boundaries and things like that. And so this is just some code that sets up grabbing that information so I have it. Now the big difference here, we still do a fig.plot, or we still make a figure, and here I've given it a fig size. We still make an axis, but now I've given the axis a projection to use. And now I'm going to call a function called pcolorMesh. And so what pcolorMesh is going to do is it's going to take some X and Y values and a 2D grid and display that as an image. So it's actually going to use quadrilateral, or it's going to make a quadrilateral mesh of the data, as opposed to some different types of plotting in Matplotlib, which Ryan will cover. And so I'm passing in to color mesh our X and Y values. So those values in meters of the grid. And then I'm passing in our variable, which is the surface temperature. And I give it time step 0. So I define that at the top here. And then I do a squeeze on that. Because if I don't do a squeeze, what I'm going to get is a 3-dimensional array out of this slice. But mesh wants a 2-dimensional array in there. So since I provided and I said I want 1 timestamp, now that first dimension is going to be 1. I can squeeze it, and altogether this will now become a 2-dimensional array. I'm saying my data's already been, it's actually in a transformed space, and that relates to my coordinate reference system. And then I'm going to add a color mapping to the field when I plot it. So the same thing, I can do the exact same thing in this case with a matplotlib function called text. So I can put an X in the center of my bounding, or from the center of the bounding box I originally requested. And then I can add some coastlines and some features like the states, general borders. I can tell it I want my grid lines to be on. It'll be lat long grid lines. And here I'm plotting the title. I'm actually plotting the timestamp we're using, and I want it output in an ISO format. And so that's some datetime library stuff. And so I executed this cell, and it's doing all of those things. And hooray, we've got a color image of surface temperature from the HER 2.5 kilometer data set that lives on a server somewhere else, not on my hard drive. And I've just requested exactly what I wanted. I got that back, and here we go. Now it's missing, it's missing a color bar, and that's kind of lame. So if you want to add a color bar to it, you can do AX, so axis dot color bar. And then we need to give it something that we want the color bar to represent. So when we did our mesh plot, pcolor mesh, I saved that off as mesh. And so I want the color bar to use this mesh thing in order to make its color bar. Oh no.
It's not PLT.
No, I know I can do PLT. Or wait, I'm gonna do fig. Fig.color bar. Yeah. So there we go. Now it'd be really nice if I could put what unit was here along my color bar, because I mean I can look at it and it's Kelvin, but that's not too helpful. So all I need to do to change that is I've got my fig.colorbar mesh. Let me save that as a variable. We'll call it CAX, color bar axis. Now I can do CAX dot label. And I could hand code it in there, or I could actually pull what the unit is out from the netcdf file. So we said NC var was our temperature variable. Dot, not Unidata, units. Oh, is it set label? I bet so. Yeah. Okay, so I did my color bar. I saved that out as a color bar axis, which is just a matplotlib axis. And what I did on that axis, that color bar axis, I said set label. And then from my netcdf variable, I said units. And now I've got K next to my color bar. Hooray. Not too bad. So there are a few things you can do and consider. Oh, question?
Is it easy to change the units of that NC data into like Fahrenheit or Celsius instead of using like Metpy?
Yeah, we could do that real quick. So where we grabbed our data, where do we actually read temperature in? Oh, wait. I think down in the plot is where I read it in. Sure enough. So I read it in here. So what I'm going to do, I'm going to create something called my, let's say, plot variable, plot var. And I'm trying to keep it generic so that somewhere in my script I can just change the name of the field I want. And then I can rerun my script and get a nice color image of that field with the appropriate units and axes and titles and things like that. So I'm going to just keep it generic. I'll say plot var, and I'm going to copy this from my mesh. Let me blow that up here. Yep, blew that up too big. So I've got plot var, and I'm going to copy from this mesh command, or this pcolor mesh command, my variable. So I'll go back down here and replace that with LTVAR. All right. And so we know NCVAR has certain units on it. So first I want to use Metpy. Units. So I'm going to multiply NCVAR, my single time step squeezed array, by units dot a. I'm going to put that in parentheses. And now I'm going to say, so that'll give me an array with units in Kelvin. So I'm going to say dot to big units dot big C. You know what? Maybe the best thing to do is also units dot big K.
Looks like Kelvin.
Okay. So units dot Kelvin, and I'm going to go to units dot deg C. So if I execute that, okay, so now we're in Celsius. I didn't update the command that was making my label for the color bar, so it still says K. That's lame. That was the last function and call I made down here. So I can actually just change that to PLTVAR since I saved that out as a separate variable. And now I'll get it correct. So deg C, now we're in Celsius. Now if I went back up here to the cell and I said, you know what, I want it in degrees F, I want Fahrenheit. So I just change the C to F, rerun the thing. Now my image will show me the surface temperature in Fahrenheit, and it's got the appropriate unit there on the color axes. And yeehaw. So I know it's getting close to lunch. There's one topic left in this notebook. It deals with grabbing point data out of model grids using the netcdf subset service. So instead of saying, I want a latitude, longitude bounding box, I'm going to say, you know what? I know there's a station at this latitude and longitude, and it's measuring temperature. And what I would like to do is go into the HER and grab the grid point closest to that latitude, longitude, and pull back the time series of temperature from that and compare it to the observations. Now, if you were going to dig through a model output file, especially in GRIB, and try to look for a single grid point that contains the data for a given latitude and longitude, that's not a trivial problem to do. And if you want to change the model that you're making that request to, if you want to change the model output file, it's going to be a different resolution, so your indexes that you figured out aren't going to work, and it's just a nightmare. But the netcdf subset service will allow you to make that kind of request on the remote data set. And we're actually going to use our same NCSS object that we've already created, but this time I'm going to create just a new query. So I broke it down here. I'm saying give me all times, give me netcdf4. I want temperature on the isobaric surfaces. I want dew point temperature on the isobaric surfaces, and the UNV wind components. And I want it for the grid point contained at, or closest to a given lat lon. So this is the center of my lat lon box that I gave. Now what it's going to actually do is it's going to give me, because these are on isobaric surfaces, so it has multiple pressure levels, this is going to give me the data for temperature, dew point, U and V along the vertical profile above that lat lon, or the grid point closest to that latitude and longitude. And given the variables that I've requested, and building off of what we just did with Ryan, we can now look at model SQTs, or SQTs made from model output for a given lat lon. So you know there's a special sounding that was done at 18Z at Norman. So let me put in Norman's lat lon. Let me grab the modeled environment's sounding information, and I'll compare that to the real sounding stuff from the RAOB and see how well the model's doing at this particular point in time. And, you know, make some educated guesses about whether to chase or not to chase, or can I make a drive to where I think I might be going or not, or what have you. And so this is the same kind of setup we did with, or you guys did with Ryan. We grab some variables that we need. We make sure we give them units. In the previous one, you had to hard code the units. And this one, we're just grabbing it out of the netcdf file that we got back from the thread server. And then I'm going to transform those into the units that I want on my SQT. And then I'm going to plot the SQT. So just executing those cells. We see we got a SQT here. Oh my God, I made that too big. It looks kind of lame though. It only goes up to 500 millibars, and it looks like there are 1, 2, 3, 4, 5 levels. Well, that's what the HER coming from NCEP over NOAA port gives us. NOAA port can only transmit so much information before its bandwidth is gone, and well, they decided to truncate the output to 500 millibars. Now, there are other models out there with more levels in them, more vertical levels, like the GFS quarter degree. And so as an exercise, you could go through and try to change this code to find the latest GFS quarter degree model and pull out the temperature profiles from that and plot it up, see what you got. So I think, Pete, you were saying the GFS quarter now goes up to 1 millibar. They just recently added 7 to 1. So there should be plenty of stuff in there for you to have fun with. So technically we're 1 minute over. Sorry about that. And I know we went through the SQT stuff with the model data pretty quickly. But hopefully what you can leave this session with is knowledge that if the data is living on a thread server, there's a good chance you can use what's called the netcdf subset service. And that will allow you to make data requests using latitude, longitudes. You can even give it date time strings and say, I just want from this start date to this end date. And then you can further go down and say, rather than just over the lat lon bounding point or bounding box, give me the data that you've got for the grid point closest to this lat lon. And you can all do those requests and queries using Python and using Cartopy. You can geolocate and project your 2D imagery onto maps and globes and make pretty stuff. And it's not that much more information you have to add to the plotting in order to do that, thanks to Cartopy. And so this is definitely one of those notebooks that, you know, if you get a fresh copy of the notebook, you know it's going to work, and you can play around in that sandbox from there and get a good feel for these libraries and how they work together. Even though I don't think anyone maybe envisioned all these different things merging together, except I suppose us, since we made this notebook. So just a heads up, with Cartopy, if you go to their documentation, they're going to show you lots and lots of things where you're plotting data using Latin lons that are already computed. And sometimes you'll get model output that will have Latin lon in it. And in that case, it's great. But for almost everything that comes back on NOAA port and everything that's on the AOS thread server and all the model stuff that's on the Unidata server is not going to have Latin lon computed for you. So if you need examples of how to compute Latin lon from these X and Y's and get it plotted on a figure, this is pretty much all that exists at this point. So if you have problems and say you're doing a projection from another model and it's using a different projection that's not, you know, Lambert conformal, then feel free to email us and say, hey, I'm trying to do this polar plot and I know there's no polar stereographic projection. There's a stereographic projection. I don't understand how these parameters match up. Can you help me out? Yeah, we'll do that. Email us and that'll be great. If you email the Cartopy guys, I don't know what your response would be. So I don't know if I would hope they've done stuff like this, but it's not in any of their examples yet. So please, please, please feel free to utilize us. We're here for you guys. We love you and it's lunch, so peace out.
Start up again at 1:15.
1:15.
I have the Firefox crash.